Next speaker is Professor Juan Luis GÓMEZ PINCHETTI. He is a professor at the University of Las Palmas de Gran Canaria, and he is also at the Faculty of Marine Science and Scientist at the Spanish Bank of Algae, BEA, of the University of Las Palmas. He's very active in this field. As mentioned at the start of this session, due to the different time zones, but he shared his video. I'd like to ask for your understanding as to this. The title of the second presentation is The Collection at the Spanish Bank of Algae as a Tool for Macroalgae Conservation and Innovation in the Blue Biotech Sector.
Good afternoon in Korea. Good morning because it is very early here in the Canary Islands. Many thanks to the World Ocean Forum and Mavic responsible for the invitation to share with all of you our activities at this Marine Bio session in this exciting Forum 2023. As an outline, this presentation will be focused on the role of our culture collection as a tool for microalgae conservation and innovation in the blue biotech sector. We will discuss about the latest developments and projects in which, while characterizing new strains or species of microalgae and cyanobacteria from the conservation point of view, these are also evaluated for biomass production under controlled conditions. Metabolites with biotechnological interest for the development of the sector are significantly studied. But let me introduce the place where the Spanish Bank of Algae from the University of Las Palmas de Gran Canaria carry out activities in the sector of algae conservation, cultivation and development of biomass application for the biotechnological sector in the Canary Islands and Europe through the different projects that we perform. BEA is located at the marine scientific part of our university in Taliarte Harbour, island of the Gran Canaria, where we have been working for more than 30 years. From the biodiversity point of view, the Canary Islands are included in a biogeographical Atlantic region called the Macaronesia, together with the archipelagos of Azores, Madeira, Green Cape, and the African Northwestern region. Marine biodiversity is highly representative in the region, particularly considering macroalgae species which have been deeply studied, characterized, and in some cases exploited for the industry. However, activities related to microalgae, including cyanobacteria identification, conservation, and their possibilities for the biotechnological sector have been developed very recently. Moreover, the role played by algae, macroalgae, microalgae, and cyanobacteria as an interesting emerging and strategic sector at the European level by considering the amount of initiatives, scientific programs, guidelines, and roadmaps is highly relevant nowadays and is strongly related to the objectives of the blue bioeconomy. These objectives are focused on the potential of marine biodiversity and the sustainable transformation of renewable marine resources into targeted products and services towards the generation of multiple innovative applications in sectors such as food and feed, nutraceutical, pharmaceutical, and cosmetic, among others. The discovery of new metabolites from different groups of algae biodiversity produced under controlled conditions also opens the door to the development of new products, services, and related applications for a continuously growing market. In addition to these basic functions of bioprospecting, isolation, identification, polyphasic characterization, and long-term conservation of the strains, BEA develops programs for the cultivation, production, and characterization of algae, biomass, and compounds for applications such as functional metabolites for food and nutrition and health applications, algae for animal feed and aquaculture, bioactives, as an example, antibiotics, antiviral, antitumor, or antifungal activities, metabolites for the cosmetic industry, including pigments or antioxidants, process for bioremediation, environment and biodiversity, what we call ecosystemic services, or agricultural applications, such as substances for biostimulants or biopesticides, all under the frame of the United Nations Sustainable Development Goals. At the BEA Culture Collection, we conserve more than 2,000 strains of microalgae and cyanobacteria, mainly from the Canary Islands and the Macaronesian region. This biodiversity offers a great potential for the development of industrial applications, allowing companies, scientific groups, and institutions around the world the access to unique, barely explored genetic resources for application in biotechnological processes, representing an important and promising source of unique active compounds with potential in multiple sectors. Related to these activities, the Spanish Bank of Algae is the only official and public Spanish collection that conserves and supplies microalgae and cyanobacteria, being a member of the most important organization for the conservation of biodiversity. Also is accredited as an international deposit authority by the World Industrial Property Organization for the purposes of recognition of the industrial property and patent applications. We are also aware of the importance of a meaningful implementation of the Convention of Biological Diversity and more recently the Nagoya Protocol recognizing sovereign rights of the parties over the genetic resources and the fair sharing of the benefits derived from their utilization. The discovery of new compounds of marine origin follows a workflow that begins with the characterization of the new biodiversity identified from bioprospection and in situ sampling. It is assumed that this biodiversity will bring new chemical elements associated with potential biological activities that will meet the increased demand for alternative sources of biological-based products. Today, ex situ culture collections are also a possibility that allows access to a large potential of genetic resources, as they are coordinated through European platforms such as MIRI, the Microbial Resource Research Infrastructure, or MBRC, the European Marine Biological Research Centre. The role of these research consortia is also relevant in the implementation and development of the procedures established in the Nagoya Protocol on access to genetic resources, as we have already commented. We carry out processes covering from the bioprospection in different environments, as is seen in the examples, to the work at the laboratory and pilot scales. These examples show Dunariella growing in salt marshes at the east coast of Gran Canaria, sampling at the Tagoro underwater volcano in the island of El Hierro, sampling along red tide events in the islands, and venting sampling of cyanobacteria, as it is the case of Limbia majuscula in some coastal areas of the islands. We work with different techniques for the identification of microalgae species, including microscopy and molecular biology procedures. It is very important to notice that many isolated strains at our collection are new descriptions for the Canary Islands and even new descriptions for science. At the laboratory, we develop a program for selection of microalgae and the identification of their potential for cultivation and products or ecosystemic services identification. This selection program includes growth characterization, biochemical and physiological performance, and possibilities for industrial cultivation and biomass transformation. In this slide, it can be observed how cultures under control conditions are established at the laboratory scale. In the next slides, I will describe some of the projects and examples developed with microalgae strain at the laboratory and the experimental plant. Within projects like REBECA or SEACOLORS, we have studied the influence of growing conditions on the synthesis and accumulation of different metabolites such as lipids, including fatty acids, pigments like phycobiliproteins and carotenoids, including fucoxanthin, astaxanthin, or beta-carotene in relation to the growth phase. The effect of nutrients has been also characterized as influencing carotenoids contents in strains of Eulena or Allochlorella along the growth curve and identifying exponential or stationary growth phases for biomass sampling and harvesting. Polysaccharides, exopolymeric substances, and beta-glucans have been also identified in some strains of cyanobacteria and eukaryotic microalgae. Characterization of extracts with biostimulant antimicrobial activities from different marine microalgae and cyanobacteria have been also identified and considered for the formulation of biofertilizer for agriculture purposes. Recently, at the European project New Tech Aqua, we have established a microalgae breeding program in diatoms with interest for aquaculture feed through sexual-induced reproduction, with the aim to identify possible improvements in traits such as growth and biochemical composition of the multiple progeny generated. Possibilities for cultivation at a pilot plant scale under controlled conditions are also carried out in order to obtain biomass for bioactivities determination in positive microalgae strain. These are also developments at the project INNOVALGA, with the aim to identify new species with industrial possibilities to boost the emerging and sustainable sector of microalgae and macroalgae in Spain through the diversification of species and applications with commercial and environmental value. In addition, an increasing number of algal species can be grown nowadays in our experimental facilities in a wide design of cultivation systems covering different scales and degrees of control. In example, photobioreactors, culture tanks for intensive production, thin layer cascades, or raceway ponds. Moreover, the concept of biorefinery by minimizing waste generation in biomass transformation processes and the principles of the circular economy or reuse of waste and co-products are being applied to maximize sustainability in the use of these resources through the development of green production techniques that generate positive impact on the environment. Scaling up all this knowledge and activities was the objective of the Savannah project, where microalgae with industrial potential were used for highly pollutant wastewater bioremediation processes in different locations in Europe at semi-industrial scale. Finally, we are involved in a collaborative program called BioAssist Gran Canaria, where the local administration, together with the university, is trying to develop initiatives related with algal biotechnology and the industrial level, with the aim to impulse the sector in the region, according to the knowledge and expertise developed during these last years and according to the Green Deal strategy of the European Union. Many thanks for your attention, and I welcome any question regarding this presentation. Thank you very much.
Well, thank you in Korean. So fun. For your reference, Las Palmas University and my institute signed an MOU last year. So I personally visited the university, and they have such a level of expertise and sophistication when it comes to microalgae. And I listened to the presentation. I think the subject is not something we are really familiar with. I will just address him as Professor Juan. And Professor Juan touched upon the potential of biomass and microalgae, and he introduced various types of projects he and his organization have been involved in. And toward the end of his presentation, he introduced the Nagoya Protocol as a CBD. by utilizing biodiversity, the profit sharing issue emerged. But he made it quite clear that everything is carried out within the framework of the UN Sustainable Development Goal. Thank you. And Professor Juan, as I introduced, he shared this presentation in the form of video. And